Welcome to the SIBO Doctor Podcast, hosted by Dr. Nirala Jacobi. Medical experts join us to discuss functional digestive disorders, clinical practice and research as it relates to SIBO and associated conditions. This podcast is intended for SIBO treating practitioners and aims to help educate how we may best serve our SIBO patients. Head over to thesibodoctor.com and sign up to the SIBO Mastery Program and take your SIBO knowledge to expert level. If you're a patient, you can sign up to the SIBO Success Plan and beat SIBO for good. Please note, this podcast series is not intended to diagnose or treat medical conditions. Ask your doctor before initiating any new treatments. And now, over to Dr. Jacobi and the latest episode of the SIBO Doctor Podcast.
Welcome to another episode of the SIBO Doctor Podcast. I'm your host, Dr. Nirala Jacobi, and today I'm speaking with researcher and author Dr. Stephanie Seneff. Dr. Seneff is a senior research scientist at MIT's Computer Science and Artificial Intelligence Laboratory in Cambridge, Massachusetts. She has a BS degree from MIT in biology and MSEE and PhD degrees from MIT in electrical engineering and computer science. Her recent interests have focused on the role of toxic chemicals and micronutrient deficiencies in health and disease, with a special emphasis on the pervasive herbicide glyphosate and the mineral sulfur. Since 2008, she has authored over 36 peer-reviewed journal papers on these topics. She's the author of a book on glyphosate titled Toxic Legacy: How the Weed Killer Glyphosate is Destroying Our Health and the Environment, which was released by Chelsea Green Publishers on July 1st, 2021. This book was selected by Kirkus Reviews as one of the best nonfiction books of 2021. Our conversation today deep dives into the toxic effects of glyphosate on our gut microbiome, our detoxification systems, and energy production system, and much more. It was prompted by my ongoing search for answers for my sulfur-sensitive patients and hydrogen sulfide SIBO dysbiosis. So hang on, it's a jam-packed podcast episode, which I think most practitioners will enjoy. Welcome to the SIBO Doctor Podcast, Dr. Stephanie Seneff.
So great to be here. Thanks for having me.
It's been a long time that I've been sort of peripherally been aware of your work around glyphosate, and also in my podcast with Dr. Nye, as I've mentioned, he referenced you a lot and your work together with him and the deep dive into the hydrogen sulfide that we did there. But I'm just so thrilled to be able to talk to you about two things. Number one was the issue of glyphosate and its effect on the gut microbiome, but also systemic issues that we face with glyphosate. And then we want to move into this other paper that you wrote with Dr. Nye about the exclusion zone water and what that all means. So listeners, you are in for an absolute treat today. So Dr. Seneff, before we dive into this topic, can you tell us a bit more about what prompted you, a research scientist at MIT with a PhD in electrical engineering and computer science, to actually investigate glyphosate?
And that's a good question. In fact, most of my career at MIT has been developing computer dialogue interactions, developing computer capabilities to correspond with humans using natural speech, precursors to Echo, Amazon Echo, and the Siri platform. But along about 2007, 2008 timeframe, I got worried because I kept seeing autism rates going up every year. And the message was, oh, we're just diagnosing it more, don't worry. And I didn't believe that. I thought there has to be something in the environment that's causing this, what I considered to be an epidemic in autism. It's continued to go up since then. So we continue to have more and more autism and still saying it's not a problem, which is really frustrating me. The government isn't bothering to check what toxins might be causing autism. So I wanted to figure out myself to take a look at various toxic elements that kids are exposed to, find ones that are going up, see if I could explain how they might be causal in autism in terms of mechanism. I have an undergraduate degree from MIT in biology, and I've always loved biology. I've always read up on stuff in biology for my whole life. So it's really my passion. And I'm so happy to be back into biology at this stage of my career. So the last over 15 years, I guess, I've been really just completely changed my direction And luckily, I had the same funder who was happy to change my direction. I submitted a proposal that was completely different from the year before, and they said fine. And every year since then, they've said fine. So it's really, really great that my funder, which is a computer company in Taiwan, has been very, very steadfastly supporting me. That's been wonderful because it means I don't have to spend a lot of time, writing proposals and things like that.
Fantastic. So glyphosate, I've been looking into glyphosate for some time, and because my big passion is the microbiome and everything gut related, and obviously as a SIBO expert and as a naturopathic physician, we always look to the gut as the cause of many of our patients' conditions. But can we start out our conversation with glyphosate or about glyphosate with how it specifically affects the microbial balance in the gut?
Right. And I should say glyphosate is the active ingredient in Roundup. I don't know if your audience all know what glyphosate is.
I know. Sorry. Maybe we should set the stage a little. Yes, it's the active ingredient in Roundup. And actually, as I learned just recently from Dr. Nye's book, it was actually initially a chelator. It was used as a chelating agent.
That's how they first patented it, as a chelator, a metal chelator, which turns out to be part of its problem too, because it chelates the minerals in the gut, making them unavailable. And that's particularly damaging to lactobacillus, which is a microbe that really depends on manganese to be healthy. And glyphosate really, really keeps manganese away from lactobacillus. And that's one of the ways that it harms lactobacillus. But anyway, so glyphosate, its mechanism of toxicity, as they've studied it, is to suppress a particular enzyme in a pathway called the shikimate pathway. And the shikimate biological pathway is very, very important in all plants. So the plants all die if they get exposed to it. So it's a wonderful weed killer. It'll kill a crop as well, but unless you give it defense against glyphosate, which they've done with these GMO crops, the Roundup Ready crops. And that's some of the major crops of the processed food industry: the corn, the soy, canola, sugar beets, alfalfa. Those are all, most of the crop grown in the United States is Roundup Ready. Meaning that you can spray glyphosate all over the crop and it doesn't die. So that's fantastic for the farmers. Makes it really easy to control the weeds. But the problem is that the glyphosate it goes up into the crop and stays there. So it actually ends up in the food and you can't wash it off. It's not like it's just on the surface. It's embedded in the tissues of the food. And so you can't get rid of it. And it's widespread in our food supply, especially in the United States. The studies that I've seen from different measures, especially Canada, they did a big study looking at the levels of glyphosate in foods and found the highest levels in foods from North America, Canada and Canada and U.S. and not Mexico. Mexico is actually sharply lower, which is interesting. So I tend to, if I have something I really want to buy and I can't find it organic, I'll buy it a Mexican version of the product, which is interesting. Yeah. And so it disrupts the shikimate pathway. And then the story is, oh gosh, our cells don't even have the whole pathway. We don't have that enzyme, our cells, and they don't have that whole pathway. So we're safe. I mean, that's the argument that Monsanto uses to say, oh, this chemical is wonderful because it kills all plants, except for those that have been engineered, and is harmless to humans. This is the message we get. And the United States government wants to believe that so badly, they don't bother to look, and meanwhile, lots of people are doing studies and finding all kinds of things. Especially recently, a lot of studies have come out in the last few years, actually, and they're coming out left and right, showing damage at many levels and in many interesting ways. And so, and part of that damage, of course, maybe most of it, or certainly a large part of it, is because it disrupts the gut microbiome. Most of the, over half of the microbes in the gut have the shikimate pathway, have a version of that enzyme that's susceptible to glyphosate. And in particular, a study showed that the microbes that are especially sensitive to glyphosate are lactobacillus and bifidobacteria. And those two are super, super important in the fetus. In the baby when it's born, those are the dominant two species in the gut. And so what happens is that those are not thriving. And then other microbes get too much of the other ones, an imbalance in the gut microbiome. And you get Clostridia overgrowth, and you get hydrogen, sulfide reducing bacteria like D. sulfur. Various microbes show up that cause trouble in terms of your gut no longer being healthy because glyphosate has caused this imbalance in the gut microbiome.
Right. And one aspect of it was that glyphosate actually blocks these assimilation enzymes. Now, just a word for the listener, when we talk about hydrogen sulfide production in the gut, it is a confusing term that we use. This is, sulfur reducing bacteria. Basically, that's because it's an organic chemistry term. It's about the reduction of sulfur. So, but for the sake of ease of of the conversation, when we talk about hydrogen sulfide production, which is so essential in many of my SIBO patients, and it's the classic ones, the desulfur Vibrio, but also we know that there are a host of other bacteria that can upregulate their hydrogen sulfide production. And I guess glyphosate actually causes these bacteria to produce more hydrogen sulfide and sulfide rather than sulfate, which is what they usually do if they're in a more regulated phase. Is that correct to say?
Yes, and in fact, there's one more thing. So I think glyphosate is disrupting both the oxidation of sulfite to sulfate and also the activation of sulfate so that it can be attached to things. That's very, very important. You make cholesterol sulfate and vitamin D sulfate and tryptophan sulfate. All of those, many of those ring molecules are sulfated before they're shipped out, so they can travel in the blood with the sulfate, which causes them to be water soluble. So that's critical for transporting all kinds of nutrients and also for transporting toxins to get rid of them. They need the sulfate to be able to ship them out in the blood. Otherwise, they're not water soluble. And so that's a huge issue, this inability to add sulfate to things, which is both sulfide to sulfate and sulfate activation, sulfate hook onto the parent molecule, putting sulfate onto a molecule. I think all of those enzymes are disrupted by glyphosate. And furthermore, what's interesting is that the enzymes that there's sulfur reducing bacteria. There are pathways that take sulfate and sulfide and turn them into methionine. It's sort of producing organic sulfur out of the inorganic sulfur. And so that's a sulfur reduction process that produces an extremely useful molecule to the host, which is methionine. Methionine is the universal methyl donor. It's an amino acid. It's the amino acid that starts off every single protein when it's made. It starts with methionine. Methionine is really, really important. And studies have shown that glyphosate suppresses methionine synthesis by the gut microbes, as well as the products of the shikimate pathway, which are also amino acids. That's tryptophan, tyrosine, and phenylalanine. So there's the three amino acids that come out of those are called those are the aromatic. Is that right? That's right. Aromatic amino acids. Tryptophan, tyrosine, and phenylalanine come out of the shikimate pathway. Glyphosate blocks that in the guts. The gut microbiome supplies these nutrients to the host. So both the methionine and these aromatic amino acids are all going to be deficient if your gut microbes are being chronically exposed to glyphosate.
Right. And in addition, it also affects the production of short-chain fatty acids, especially butyric acid. And it has all these really nasty effects on the gut microbiome. And I think this is what, to your point of saying that there's a lot of research into also the gut-brain axis and how this, all affects these aromatic amino acids that you just mentioned are all vital for our neurotransmitter production locally in the gut, but also, if they're absorbed, they do get converted.
In the brain, absolutely. Serotonin, the main production of serotonin is in the gut from tryptophan.
Yeah. Yeah, sorry. Yes, sorry, listeners. My dogs are in the office with me today because we've got a bit of construction, so apologize for things. Okay, so definitely we can see that there is this. Oh, and one other thing I wanted to say about hydrogen sulfide production, which just a recent research or discovery by Dr. Pimentel is that one of the main hydrogen sulfide production organisms is Fusobacterium, or that group of bacteria, Fusobacterium. And these, oh my God, they're so annoying, these dogs. I'm going to have to make a note of that. I'm going to have to edit that out. So that actually gets upregulated also with glyphosate. So we're seeing all these effects that clinically I do see in my practice. I see people with with high hydrogen sulfide production and low short chain fatty acids and low lactobacillus and low bifidobacterium, and not, there's all these different issues that influence this, not just glyphosate. I get that. But it just is really interesting.
It might be mainly glyphosate, I think, because it fits so well. I know there's all kinds of other toxins that we're exposed to, but these all make sense with glyphosate.
So there's also polymorphism in the FUT2 gene, which is probably very important when we talk about cobalamin, and how glyphosate has its effect on cobalamin. So let's talk. Well, before we go there, just so that the listener can continue to follow us, I just wanted to remind listeners about the symptoms of excessive hydrogen sulfide in your system. And this is really what we're talking about. And go back to Dr. Greg Nye's interview that I did with him 5 years ago, where he talks about hydrogen sulfide upregulation to some extent, so that where we're actually seeing more hydrogen sulfide production with some of these pathways that we're going to dive into in a moment. But really, if you are suffering from eye irritation, like a lot of itching, conjunctivitis, or photophobia, or neurological symptoms, dizziness, headaches, lack of concentration, memory loss, unstable moods, behavioral issues like anger, depression, tension, fatigue, and nausea, low libido, it's just there's a lot of people, right, that have these symptoms, and a lot of lung issues as well. It could be that you have a sulfur issue. And what we're going to move into now is how glyphosate really affects sulfur and its metabolism to a usable form of sulfur or organic sulfate that is used by so many different systems in the body. I hope that was a good segue into.
Yes, I know. It's so fascinating. And of course, I actually got interested in sulfate before I even knew about glyphosate, long before. And when I first started looking at autism, I started reading things that had been written about the autistic kids. And I came across Rosemary Waring's work. Do you know how much? I don't know how much you know about autism, but Rosemary Waring was working in the 1990s with autistic kids. And she was quite an expert trying to heal them. And she did some measuring of things in their urine, and she found shockingly high levels of sulfur metabolites in the urine, like sulfide and thiosulfate, incredibly high levels compared to the normal controls. And then she found low sulfate in the blood, and she suspected that they had some issue with sulfation pathways, with enzymes that were involved with sulfate, and she was spot on. This was, of course, in the 1990s, and these kids may have had genetic issues that were causing their problems at that time because glyphosate was much, much lower. But now I think we're seeing a lot of these autistic kids. It could be a genetic predisposition that the enzyme is already weak. And then on top of that, it gets the glyphosate, disrupting it even more. And then you start to see the symptoms. But I think sulfate deficiency and mismanagement of sulfate really is a crucial, I think, central to autism.
Well, and let me say that I have never, I've been in practice for 25 years, and I've never seen so much sulfur sensitivity. Right. So this is where the rubber hits the road in a way, because we're dealing with people that have an intrinsic organic sulfate deficiency, because the things that we just talked about clog up the machinery, the intracellular machinery that produces organic sulfate that is usable by the body.
Organic sulfate is not quite what I would call it, but methionine is an organic molecule containing sulfur, and that's the reduced form. Hydrogen sulfide is kind of stuck onto this amino acid. It's a sulfur-containing amino acid, and then methionine can be converted to cysteine, which can be converted to homocysteine, which can become sulfate. So there's these organic molecules are sort of hidden sulfate transporters. They're moving. They can move around in the body much more easily than sulfate can. And when they get somewhere, they can be turned into sulfate. But if those are deficient, then you need some other way to get sulfate. And another molecule that can get turned into sulfate is hydrogen sulfide gas. But it's not a good way to transport it. And what I think is really happening with these people is that the whole system that transports sulfur able to become sulfate, I should say, through some chemical reactions, that system is derailed in many ways by glyphosate. And so the only way that's left that avoids glyphosate is the hydrogen sulfide bath. For example, I mean, it's like one of the very few ways you can get the sulfate to where it needs to go, which is quite interesting in my opinion, which is to let the gut microbes convert it to hydrogen sulfide gas, which is a gas, very tiny gas. It moves through your tissues. It doesn't even need channels. Like, it doesn't have to go in the blood or in the lymph system. It just goes straight through the cells because it's so tiny. And it diffuses up because it's lighter than air, right? So it goes up into the brain. And in the brain, the cells in the brain, the neurons can grab it and turn it into sulfate. So it's a really interesting sulfate transport system that's not a good one, because the hydrogen sulfide gas has all these issues that, as you just mentioned, all these different symptoms that are associated with its presence. It's actually toxic. It can kill you if it's in high concentration. People have died from exposure to hydrogen sulfide gas, but it's a signaling molecule and it's present naturally in the blood, and the cells make it. And they use it effectively as a signaling molecule in small amounts. But when you have this problem with not being able to get the sulfate to the brain any other way, the body becomes desperate. It says, well, let's do it this way. It's sort of the only thing left that works, that still works, with the glyphosate messing up everything else.
That's really, the most important, I think, information that people need to understand, because so many people that I see that are sensitive to sulfur don't understand that it's a compensatory mechanism, in a way, that your body is trying to achieve a certain goal, and it does so even if you're symptomatic as heck. So
yeah, and then of course, if they go for a low sulfur diet, you end up with systemic sulfur deficiency, because you're sensitive, so you avoid sulfur containing foods, and now you've got an even bigger problem.
I have a few patients like that are just absolutely, ultra sensitive, and that's more the exception. But I've never before, seen people at that end of the spectrum of where they really are so completely intolerant, and it's difficult because they're so dysregulated, But let's go back to that. Sulfur is so critical in so many systems, right? Can you talk about some other important functions of sulfur?
Mm-hmm. And the sulfate in particular, and that's something that Greg and I share, which goes along with Jerry Pollack. And have you Jerry Pollack? Do you know who he is? He's got Mr. Exclusion Zone water, So he's. I ran into his work early on, and I met him. He's a friend of mine now. He's a great guy, and he's a friend of Greg's as well. I think that's how we met. Actually, we met through a mutual contact with Jerry Pollack, and Jerry has just had a wonderful career investigating water. And the fourth phase of water was one of his books, which is excellent. His books are fantastic. They're really written for the lay public. They're not easy, but they're much more accessible than the research literature in that space. So I highly recommend his books. There's the fourth phase of water, which is the newer one. And then Cells, Gels, and the Engines of Life was the earlier one. I've read both of them. They're really, really great. And they explain this unique property. Water is a really, really interesting molecule. Of course, it's essential for life. And it has, every element, every sort of materials can be characterized as having different states at different temperatures and pressures. You have the liquid, the gas, and the solid, right? Sort of in chemistry, those are kind of the three phases of different things. But water has this fourth phase. That's the title of the book. The fourth phase of water is gel. And so gel is kind of a unique property of water. And gel is something that the body essentially depends on to stay healthy. Most of the water in your body is in this gelled form. And it's like Jell-O. I mean, Jell-O is basically gelled water. So you can think of Jell-O to understand it. You think about Jell-O, you put a little packet of just some powder and you put in some boiling water, stir it up, put it in the refrigerator, and then it becomes almost like a solid, right? It's no longer something you can pour out. And so we take it for granted because we're used to it, but it's really, really unusual that water does that. And that gelled phase is where a lot of the action is as far as how the body works. And so the cells, so the blood vessels in particular, line themselves with sulfate. The sulfate is sprinkled throughout the vasculature. Sulfate is attached to the molecules that sort of line the blood vessel. And the sulfate makes the water gelled nearby. So what happens is you get this gel layer, this layer of gel inside, coating all the blood vessels on the inside. And the gel then has a very slick surface, just like Jell-O. It's very slick. It's very low friction, which allows the red blood cells to slide through the capillaries rather effortlessly. And that's really important because when when there's a lot of friction, if there's just water, and then you've got all these molecules sticking out from the cell, from the lining of the blood vessel has all these things sticking into the water, it's going to slow down the red blood cell when it tries to get through, because it's kind of a tight squeeze for the red blood cells in the capillaries. So they need to have that very frictionless surface to just slide through. And the gel helps them to do that. And then, of course, the red blood cells also have sulfate in their membrane. And almost everything that's suspended in the blood has sulfate in the membrane. There's cholesterol sulfate, which is a really important sulfated molecule that goes into the membranes of the red blood cells, and also of the lipid particles, the LDL, the HDL. These are the particles that they talk about for statin drugs. Your cholesterol is high, you've got high LDL. They'll put you on a statin drug if your LDL is too high. And that LDL is a particle that has cholesterol sulfate in its membrane. And the sulfate creates gelled water around the particle. And the gelled water keeps it safe from oxidation damage and from glycation damage from sugar. And so the lipid particles that are in the blood, they love to have sulfate in their membrane, sticking out from their membrane, to give them that, to make the water gelled and to give them a negative charge. And that's really important for the red blood cells, because they'll repel each other and they won't stick together. And that keeps your blood from forming into catastrophic blood clots and things like that, because the blood needs to flow nicely. The particles need to be separated. All of that works beautifully because the sulfate has negative charge. So it's really two things, the gel and the negative charge, that are both really, really important in the circulation to keep the blood healthy.
And so are you with furthering our conversation with glyphosate, how does that affect this exclusion zone water, or this gel-like water?
Yeah, the main thing is that glyphosate makes the sulfate insufficient, so that the lining of the blood vessels doesn't have enough sulfate. And in fact, it's a molecule called heparin sulfate. And when that's deficient, actually, things in the blood can cause trouble for the lining of the blood vessel. It's not protected anymore because there's no gel. And so anything coming through in the blood, even a toxin like glyphosate, can come in and cause damage. But metals, everything that could cause trouble, oxidizing agents, glycating agents, they're all going to attack the wall of the blood vessel and make it sick. And of course, that's how you start heart disease too, because you start to get these damaged blood vessels in the heart. And then you get this buildup of cholesterol. It's sort of fixing the wound, so to speak. So the blood vessel is damaged because it's not protected, because it doesn't have enough sulfate. And it doesn't have enough sulfate because glyphosate messed it up.
Mm-hmm. And this exclusion zone water, you mentioned it's sort of, I think in your paper, which we'll list it's a fascinating paper that initiated this conversation really, it's great. It's about this exclusion zone water, and I highly recommend people read it, because it really makes a lot of sense in the context of sulfur issues and sulfur sensitivities and all the things that can sort of go wrong. And we'll get to B12 in a moment. So, so with this exclusion zone water, is like how you mentioned a battery effect in your paper. So what does it charge?
Yeah, that's what Jerry really figured that out, and it's just so beautiful. It's just wonderful, and I would actually say that it really is like a battery, and in fact, sunlight charges it up. So when you go outside in the sunlight, people say, "Oh, make vitamin D." That's not the only reason why you go out in the sunlight. It's to increase the size of the battery, which is actually charging your cells up with energy. So that's really, really amazing. I think I'm a big sun worshiper, and I think that people are not getting enough sunlight exposure. And the sunlight actually directly grows this exclusion zone water. And this is, again, he showed this experimentally. It's amazing. And it's the infrared light that's especially effective, not the UV, but the infrared. And there's a lot of infrared in the winter. In fact, it doesn't go down that much between the summer and the winter. I was surprised to hear that. So you can be outside in the winter picking up infrared light, improving your batteries, across your body, even though you're not really making vitamin D because you don't have enough UV light. So it's but the battery is formed because the water forms a structure. I call it liquid ice because it has a structure similar to the structure of ice. But that structure sort of works best if you get rid of some of the protons. And so it becomes negatively charged. That means sort of pushes protons out. Some of the protons break loose and it forms these almost like circles of water molecules that are kind of ionically structured together, but they do better with the whole structure if you get rid of some of the protons. That's basically how to describe it. And so it pushes these protons out of the exclusion zone water. So you've got the gel there. Inside the gel, if you put a probe in there, it's negatively charged. And that's what he's done. He's shown that that's true experimentally. And then at the edge of the gel, it's positively charged. That's where the protons are gathering. So the protons end up gathering and they're attracted to the negative. So they want to go in, but they can't because the structure excludes them. So part of the exclusion zone is excluding protons. It also excludes other molecules. So it's pure crystalline water in a way. But it has those protons gathering along the edge. And I have talked about theoretically that those protons are actually ushered into the cell, and they pick up along the cytoskeletal pathways, like electrical wires. And the mitochondria hang on to the cytoskeletal threads, and they pick up those protons that are pumped into the cell from the exclusion zone water outside to provide the cell essentially with electricity to the mitochondria. So it's quite beautiful if it's true, and it's theoretical at this point. But I'd love to have someone do the science to show that that's what's happening, because it makes a whole lot of sense to me, but I speculate sometimes on some of my theories, so I'm waiting for people to...
You're a creative thinker, but that's how, I think what we're witnessing is really more and more the sort of the validation of energetics of what we've always known. I mean, ultimately, biochemical structures and processes are all energetically driven by ion exchanges and positively and negatively charged molecules. This is basic chemistry. So that's what you're talking about, but it can get into this, because when I looked at that structure that you described in this paper that you published and just a graphic of it, it just is so sci-fi in a way. It's amazing. And yet here we are, we're looking at these really important physiological functions of this fourth phase of water that we've never heard about, or I've never heard about in medicine. And what you say is that it's one of the most important aspects of protection in a way. If we're talking about that, it lines all of the blood vessels and it provides this energetic charge. It just seems like it has this incredible protective sort of gateway almost, that it only allows certain molecules to diffuse through. And if that's gone, there goes our protection. And that's not a good thing to lose in the 21st century when we're surrounded by toxins. So before we move into deuterium, I know you want to get there, but I wanted to talk about other aspects of what we know is important with sulfur and its metabolites, such as detoxification, right? One of the main pathways in phase 2 detoxification is sulfation, which is responsible for so many different, responsible for detoxifying so many different substances. So when that goes, that's not a good thing. And when we have impairment in those pathways, and then also hormonal productions and so many different aspects of our function, collagen production is absolutely essential with heparan sulfate. And can you talk about this aspect of glyphosate being a glycine analog, which is an important amino acid in the building of collagen, but also other structures and substances in the body?
Right. I mean, that's certainly the centerpiece of my book, Toxic Legacy. The whole book is wrapped around this concept that glyphosate is substituting for glycine by mistake during protein synthesis. And I think this is what's happening. And if it's true, then it explains why glyphosate could cause so many diseases, because we see all these diseases going up dramatically, exactly in step with the rise in glyphosate usage on core crops. In the United States, it's just amazing how obese people are today. I mean, obesity has just gone up and up and up. And as glyphosate usage has gone up and up and up, they line up extremely well. Diabetes, obesity, autism, Alzheimer's, thyroid cancer, pancreatic cancer. There's a whole list of liver disease, kidney disease, all these things going up dramatically in step with the dramatic rise in glyphosate. And so my big question was, how could, and everyone's big question is, they would say, well, this is, correlation doesn't mean causation. This can't be true, because how could one chemical cause so many things? These are the pushback that I get. But, one chemical could cause so many things if this is its mechanism of toxicity, because it's really, really extraordinary in terms of what you would predict would be happening if it's true. Because glycine is such an important amino acid, and it has many really important roles in many different proteins. And there's studies that show that when a particular glycine residue is replaced by another amino acid like alanine because of a genetic error, in a mutation, if somebody has a mutated form of that protein where they don't have glycine at that critical place, then that protein gets completely destroyed and they can be very sick. So it's super critical for some proteins at some spots to have glycine. And I've worked through in the book which proteins those would be, and also which proteins would have a glycine that's especially susceptible, what I call a glyphosate susceptibility motif, that they have a glycine in a particular spot that's especially susceptible because there's room for the extra tail. Glyphosate is a glycine molecule, complete glycine molecule, and it's got some extra junk stuff stuck onto its nitrogen atom. And so as long as that extra stuff can fit into the structure of the protein, it can go in place of glycine. So it won't substitute with certain glycines because they're too crowded at that location. They've got big bulky amino acids next door, it won't fit. But if it's got small amino acids next door, and particularly if it binds phosphate, is what I realized. If it binds phosphate or it binds sulfate, that's at that place. Often glycine is found as an essential amino acid at places where proteins that work with phosphate or sulfate bind to it. So when glyphosate puts its methylphosphonate unit into the spot where the phosphate of the substrate is supposed to fit, and now the substrate can't fit and the protein is ruined. So that's what's happening with the EPSP synthase in the shikimate pathway. It's very clear to me. That's how it's disrupting that enzyme, by substituting for a glycine residue in that enzyme that's highly conserved at the place where it binds the phosphate of phosphoenolpyruvate. So there's a little bit of technical stuff there. But the point is, if this is true, then it's like, oh my God. And that's as I started to realize this possibility and started to rummage around the research literature looking for glycine mutations and what they might cause, and then finding glycine mutations in critical enzymes that would cause various of these conditions that are going up dramatically. It all fit together like a giant puzzle, and I got really excited. But I think that is something very unique about glyphosate. I don't know of any other chemical that does this, that substitutes for glycine during protein synthesis. So it's a crucial aspect. It's a sort of insidious, cumulative toxic effect that happens slowly over time. And so we miss it. We don't realize it's glyphosate that's causing our problems because it's so slow.
Well, and it's so, sometimes when there's so many different systems that are affected, it's difficult to pinpoint one. I mean, with obesity, I'd say also the overuse of antibiotics is also probably one of the main causes, or there's lots of different reasons. And one thing is for sure, the body's getting more toxic and having to find ways to dilute that poison, and that is gaining weight because the solution to pollution is dilution. So we get water retention and we gain weight because fat tissue is a great repository for that. It's a great...
And the glyphosate's contributing to that with the fat-soluble toxins that we're stuffing into our fat cells, because the liver's enzymes that will make that fat-soluble toxin water-soluble so that it can be excreted through the urine. And those enzymes are messed up by glyphosate. There's both the cytochrome P450 enzymes, which hydrolyze these things, and then there's the enzymes that attach sulfate. So many of these toxins are detoxified in the liver by this two-step process that involves this hydrolyzing them and then sulfating them. And then they can ship them out and they can go into the blood, and they can go to the urine and go out. And so those enzymes are messed up by glyphosate, which means those fat-soluble toxins that you're exposed to have to be stuffed inside fat cells, or you're going to get sick, And I see people who are just so determined not to get fat. They're starving themselves all the time to not get fat. And then they get sick because they're being exposed to the toxins when they don't allow them to be stored in the fat cells. So we're really kind of caught with a catch-22 here with this issue of trying to stay thin in the context of facing all these obesogens that are fat soluble and that we can't metabolize properly to get rid of them because of glyphosate messing up the liver. So that's a compounded problem. There's a lot of synergistic toxicity between glyphosate and other things, and fatty liver disease is another example, and that's fat being stored in the liver. We have an epidemic even among children these days in America with fatty liver disease. And glyphosate, I think it's really a major player in fatty liver disease. And recent studies are coming out, brand new study, just this month by a guy named Mills is one of the authors on it. And they looked at children and they looked at glyphosate levels in the mother, which was pregnant. And then in the child, this is a long-term study, 5 years old, 14 years old, looking at glyphosate levels, and then looking at fatty liver disease, markers of fatty liver disease, like transaminase, I forget. There's a liver enzyme, liver enzyme that's characteristic. And then, of course, also metabolic syndrome. And they found that the glyphosate levels were correlated with obesity, metabolic syndrome, and liver disease in these children. They were just children living in an agricultural area that were being exposed to the glyphosate.
How did they measure the glyphosate? Because that's always my question is, how can we actually assess it? I do know I have a test. I don't know if it's really super accurate, but it's urine test for glyphosate. Is that the best way to assess glyphosate in people?
That's what people are doing. And of course, and they admitted in the paper that it's suboptimal because you're only looking at their exposure over the last couple of weeks.
Yeah. And what they're excreting and not what they're storing, right?
Right. That's another issue, too, what they're excreting rather than what they're storing. And the fact that it's only over a two-week window, it might be that they got sprayed a month ago and now it's gone, so it's very hit or miss. So it's actually really impressive that they got statistically significant results despite those limitations of the methodology, because it's really difficult to be able to measure, in that way. And I'm actually amazed that they still get they can see it just from that simple procedure.
And you also mentioned, I think maybe not in this paper, but somewhere I read it about that even people that, like myself, I eat pretty much 100% organic. I haven't measured my own glyphosate levels, but that even people that make a huge effort to avoid conventionally grown foods and only eat animal products that are organic. So why is it showing up in even people that eat organic?
I know. That's really frustrating, isn't it?
Very depressing.
Yeah, I have a friend, Anthony Samsel, who we collaborated on a number of papers, and he's been doing a little study where he has people sample the rainwater in different parts of the world and then send him the sample and he tests it for glyphosate. And I sent him samples from Cambridge, Massachusetts, where my office is at MIT. And I sent him a sample from Winchester, my home, which was a suburb of Cambridge. And then I sent him a sample from Kauai, where I live now, which is in Hawaii. And both the Winchester and the Kauai samples came out negative, but the Cambridge one did not. So it's in the rain. The glyphosate's in the rain in Cambridge. It's in the air is basically what that means. It's in the air. It's in the water supply in many cases. People live near agricultural fields, or your neighbor's using it on their lawn, so it's really, really hard. And it's even in organic food. Organic foods are testing positive, much, much less than in non-organic, but not zero in many cases, especially in the US.
Much less is what I needed to hear. Yeah. But if it shows up in the rain, so is there a filter because I think it's a super small molecule, right? Like it's not a big molecule.
Yeah, reverse osmosis filters can take it out of the water, but those can have issues with keeping them clean, because if they get all gummed up, then they're worse than useless. So it's not easy to filter it out. It's much better to not have it in the first place. The best way to get rid of it is to ban it. So Mexico is doing that. Mexico is banning.
Right, France and Germany in 2023, I was reading. So this year is supposed to be the last year anyways.
Yes, they keep renewing it, but I think Mexico is really I've been rooting for Mexico because U.S. has been pressuring them really hard, trying to find a way to get them to stop the ban. U.S. does not want Mexico to ban glyphosate, which just breaks my heart. My country is just we're like the world's leader in glyphosate.
America has all kinds of issues.
I know. Don't tell me that. I know it well.
Do you have SIBO and want to learn how to help yourself? The SIBO Success Plan is now available from thesibodoctor.com. In this highly anticipated plan, you'll learn my tried and proven method to treat SIBO, including home treatments, online dispensary guides, diet handouts, and much, much more. Already being treated by a practitioner? No problem. The SIBO Success Plan is designed as a standalone program or to work under the care of a practitioner. Become a SIBO-savvy patient and beat SIBO for good. For more info, go to www.thesibodoctor.com.